Welcome everybody. Thank you for joining us on another webinar by Logisoft. My name is Nick Zulfikar. I'm the Director of Client Services here. With me is my colleague Ron Hussain, who's our Senior Technology Evangelist. Today we're going to be talking about two of the most popular caching platforms out there, distributed caching solutions. First one is NCache, which is a private .NET, a native .NET cache. It's a highly advanced and stable product that's been in the market for over 10 years now. The second one is going to be Redis, which is by Redis Labs, and Microsoft is pushing it in Azure these days as a default cache. Ron will give us a detailed comparison of the two products, specifically the qualitative aspects such as performance, scalability, high availability, and administration, etc. So feel free to type your questions in as you have them in the box, and I'll let Ron get started with the presentation, and I'll jump in with the questions as they come up. So Ron, kindly take over, please.
Thank you, Nick. Hi, everybody. My name is Ron, and as Nick mentioned, I will be your presenter as far as tech details are concerned for today's webinar. Today we'll discuss some of the major differences between NCache and Redis, how NCache is a better fit for your .NET and .NET Core applications, and what are the advantages that you get over Redis if you plan on using a distributed caching system into your application architecture. So this is going to be a detailed feature by feature comparison. I have some hands-on examples lined up that I'll showcase as part of the differences that these two products have, and how NCache is going to be handling those scenarios. So let's quickly get started. I hope everybody can see my screen, and as Nick suggested, if there are any questions, please feel free to stop me, and I'll be very happy to answer all those questions for you. All right, so typically, let me build some background details on what exactly a distributed caching system is and what challenges a distributed caching system in general helps resolve for your applications. So first of all, we have the scalability problem. Your application tier can scale out nicely. There are concepts of creating web garden, where you can distribute load on a given server between different worker processes, and then you can also create a web form by distributing your application load on multiple web or app servers. So your application tier scales out nicely within .NET and .NET Core applications, but typically you need to actually talk to a backend data sources. It could be your relational databases, it could be some file system, some legacy data source. So that platform itself, that data source, is not meant to handle extreme transactional load that your applications are putting onto your application service. Since application servers have to talk to the backend data sources, so data storage becomes a bottleneck where it's not able to give you extreme performance, and specifically under peak loads, it tends to choke down. NoSQL databases are not always an answer for this, primarily because NoSQL data sources demand that you replace your relational data sources and start using NoSQL databases, and you need to re-architecture your applications to start using that. We also have a NoSQL database product. It's called NOSDB, but today's focus is going to be performance and scalability, and using data sources, relational data sources, in combination to our in combination to a distributed caching system. So distributed caching system like NCache is going to help resolve all the relational database or legacy backend data sources challenges. Primarily we'll talk about performance and scalability. How in-memory distributed caching system like NCache help address these problems. Basically they are in memory, so it's storage is always going to be in memory, so it's going to be super fast in comparison. And then you can scale out the caching tier as you would scale out your application tier. So you can put 2 or 3 caching servers using NCache, and then you can add more and more caching servers on the fly, and as you add more servers, it increases the capacity of how many requests you can handle out of the system. So it's pretty extendable in terms of number of servers that you can add, and you can do that on the fly. and this is one of the key differences between NCache and Redis. And by doing that, you actually attain more and more scalability, achieve more and more scalability out of the system. And you use distributed caching systems like NCache in combination to our relational database. It does not replace your existing relational data sources or legacy file systems or mainframe data sources at all. So it's something that you use in combination. This is a typical deployment of a distributed caching system like NCache. I'm going to use NCache deployment as an example. You can choose Windows environment. You again use .NET or .NET Core servers. You can use Linux servers. Again, you would use .NET Core. NCache fully supports .NET Core, so you can use NCache on Linux environment, and then Windows Nano through Docker. And Linux is also available through tar.gz setup or through Docker, right? So server-side deployment is pretty straightforward. You only need .NET or .NET Core frameworks as prereq, and then based on your preferred operating system, you can deploy distributed caching system like NCache on your preferred platform. So you can start off with 2 or 3 caching servers, and then you can scale out nicely by adding more and more caching servers. And your application tiers, they connect to NCache in a client server model. Again, they could be on Windows or on Linux environment, ASP.NET or ASP.NET Core Web Apps, .NET and .NET Core Web Services. Similarly, any other server applications, .NET and .NET Core, and we also have Java client that you can use if you're interested in the Java side of the world. And again, your backend data sources are going to be used in combination to a distributed cache. Most readily accessed data is retrieved from the cache because it's faster, it's more scalable, it's highly available, it's more reliable in comparison to your backend data sources. Some use cases, and then we'll target the differences between NCache and Redis. You can use distributed caching system like NCache in application data caching, primarily to help address all the data store, relational databases, or any data source related performance and scalability bottlenecks. You can use object caching API, and you can utilize data from the caching, which is faster, more reliable, more scalable in comparison to data source. You can cache almost anything using our application data caching features. Primarily, you can use APIs to cache your domain objects, collections, data sets, images, any sort of application related data that you normally get from the backend data sources. You can use the data caching model, app data caching, in order to use a distributed caching system like NCache to improve application performance and scalability. Then for web applications, ASP.NET and ASP.NET Core side of the things, these are almost no code change options. You can use ASP.NET or ASP.NET Core session caching. That's something that comes as a provider. On ASP.NET Core, it's an iDistribute cache provider. You can use session through iDistribute cache, or you can use NCache ASP.NET Core provider directly as well. And with minimal code changes in startup.cs, you can plug in NCache provider without having to be going through the details of implementing this yourself. Then SignalR backplane, again in ASP.NET and ASP.NET Core, NCache can act as a backplane for this. So that's another use case. Then we can use it for response caching. ASP.NET Core, previously was output caching in ASP.NET. In ASP.NET Core, it's termed as response caching. So NCache can be plugged in for response caching to help address any static content related problems. So your content is static, you don't have to re-execute it, you don't have to go to the backend databases, you can just cache that response and present it on the subsequent requests. Then for legacy applications for ASP.NET side of things, if you have web forms, you can use view state caching. That's another use case. And then you can also use for web forms as well as for MVC applications, you can use output caching out of NCache. So these are essentially no code change options, plug and play providers. NCache has written providers, and you get a lot of benefits when you plug in a distributed caching system like NCache into your applications, and you start getting performance, more scalability, more reliability into the architecture. Maintenance becomes a lot easier. No sticky session load balancing needed, and you can extend this use case based on the expected user load from your applications without changing anything on the application architecture side. Then third important use case, if you guys have some backend processes, some microservices, there could be a need of app coordination between those microservices. So NCache comes with a PubSub messaging and events platform. So it allows you to use NCache as a communication channel, and you can create topics where publishers and subscribers can connect, and based on topics of their interest, they can publish messages, and those messages are going to be communicated to all the subscribers. And this is a loosely coupled setup as PubSub demands it, and then NCache can be used as a communication channel for that. On top of it, NCache also has some data source related events, some item related events, and then you can also set up criteria and get events based on the criteria that you set up. So based on the criteria, data can be mapped in NCache, and on that data you can get events out of NCache. So it has a lot of different kinds of messages and events that you can utilize. Primarily it's a PubSub messaging platform that NCache is providing. So these are some of the use cases. I wanted to cover tech use cases, business use cases. You can use it in different kind of industries. Airline industry for ticket management, e-commerce industry can be another go for it. IoT is another emerging use case for it. So any application, public facing or internal, which has a challenge of performance, and it also needs to address scalability or reliability related issues, it can use a distributed caching system like NCache. NCache, as Nick earlier on suggested, that it has been in the market for over 10 years. Actually, it's more than 13 years now. It was launched in 2005. Current version of NCache is 4.9. It is also available as open source, and it has lots and lots of active deployments. You can see some industry verticals showing NCache deployments: banking industry, e-commerce, airlines, healthcare, and list goes on. All right, so I wanted to spend 5-10 minutes on the concept of distributed caching in general. Please let me know if there are any questions. Otherwise, we'll target our main topic today. We'll discuss NCache versus Redis. I have formulated this presentation into different segments. First segment is platform and technology. So this is what I'm going to cover next, how these two products compare and how NCache is better in comparison to Redis from platform and technology standpoint. All right, the core concept of NCache, and they're similar products. It's a distributed caching system. They store everything in a key value pair. But as far as development of NCache is concerned, it is a native .NET developed product. And by release of .NET Core, we've also made it available for .NET Core as well. We've rewritten, we recompiled our code with .NET Core and made some enhancements using .NET Core framework. And it's available on .NET and .NET Core frameworks natively. It's fully developed in .NET using C#, and it allows you to deploy it on Windows as well as on Linux environments. In comparison, Redis, it's written in C++, so it's primarily focused for from a standpoint of deployment. It's on the Linux side of the world, so it's not native .NET. So a developer coming from .NET background, they would prefer a product which is also written on the .NET, so their maintenance becomes a lot easier, right? So they're comfortable with Windows platform, and then a product which is using .NET framework in comparison to Linux and C++, a .NET developer would be more comfortable from a platform standpoint. And then on top of it, NCache has some server-side code which are also written on the .NET. So Redis lacks those completely, but from a developer standpoint, those are some developer features that you need to develop. What if you have to write such features in C++ or Java, whereas your entire stack is in .NET? So that would be a fundamental difference between these two products, where NCache is a native .NET and .NET Core product. Redis is not. Redis is a C++, and preferred platform for NCache is Windows, again using .NET or .NET Core, whereas Redis uses Linux for that matter. From a support standpoint, NCache is fully supported using .NET and .NET Core deployments on Windows. You can use 2012, 2016 servers. It's officially supported from our end. We also have Windows Nano. It was a beta version, and we're also working on the Docker image for that to have it officially supported from our end. So it's officially supported as we speak, but it is currently in the beta version. And we provide full support in production as far as your Windows deployments are concerned. End-to-end .NET and .NET Core support is going to be extended for your production deployments. On the other hand, Redis Windows, it's not an official version to start off. Even Redis Lab and Microsoft Azure are using the Linux installations to support their customers. Microsoft OpenTech gave a ported version of Windows for Redis. It was buggy, it was unstable, and it was not officially supported. There was not a production official support for production deployments as far as Windows environment is concerned. So I will bring back the concept of a developer who is more comfortable with Windows platform, a .NET developer. They would prefer a server-side product to be also on the same stack as well. It could be a showstopper for developers if they have to learn a new set of expertise. They have to go through C++ development cycle, and they also have to review the environment and all the monitoring aspects or administration aspects or learning aspects of that environment if they're not comfortable. So from a Windows standpoint, NCache is a lot more mature. Redis completely lacks this support in comparison. And if I quickly show you the demo environment, I have environment set up. So from GUI standpoint, you can use NCache, and I'll just open NCache cache. Let's open this clustered cache, and you can see I have, let me just add another server here. So this is my Windows cluster. All right, so I think it's already added. There you go. So it's already added, so that's why it complained. So we have 107 and 100 as clients, and I can add as many clients as I need to. So this is going to be my Windows environment. I'll show you a complete demo at a later stage as well. And this is my Linux environment. If I just have to show you the caches, let me just open the caches, and you can see my caches are running on 117 and 118. I just created a cache to demonstrate that it's supported on Windows as well as on Linux environment. And similarly, if I show you the cache on 117, that's another Linux box. Oops, there's a typo, so let me just correct it. Right, so we have a cache cluster showing the same output. So this was a output from 118. I had two servers, 117 and 118, both Linux boxes. And similarly, I've shown you the same output from 117, and it shows a fully connected cache cluster. My personal, the box where I've logged into is a client, which is again a Linux. And similarly, the Windows environment is going to be the two servers, 107 and 108, which I'll be using for demonstration. Then my machine would be used as a client for that matter. So it's fully supported. We have GUI tools and PowerShell tools on Windows side, and on the Linux we only have PowerShell tools that you need to be using. So it's fully supported on both Windows and Linux environments. Windows through .NET and .NET Core, Linux through .NET Core only. And as far as Redis is concerned, it's officially supported on Linux, as I've explained. Azure and Redis Lab, they are actually supporting Linux version, and Windows supported version is buggy. It's not officially supported in comparison. Then from a client standpoint, is there a question?
Ron, I have a question. Yes. What sort of monitoring options do we have for NCache running on Linux?
Okay, this is a very good question. Since .NET Core itself is launched newly, right? Its perf mount counter support is not that stable on the Linux. I think it's not available on Linux side as we speak. So from a monitoring standpoint, we have extended NCache monitoring support for Linux setup as well. If I have to quickly add one of the boxes, I'll show you that you can fully monitor Linux side of servers using the Windows box as well. So here is my Linux server, Linux cache using .NET Core, and if I right click on choose statistics, I can open the perf mount counters, and if I run some activity, I should be able to see all the perf mount counters directly from Windows. So this is a support that we've extended, and primary reason for that is .NET Core on Linux does not have perf mount counter support as yet. I'm not sure how that would be planned, but this is how you would monitor NCache on .NET Core for Linux environment.
Okay, thank you.
Very good. All right, so moving on from a client standpoint, again, I've shown you a .NET Core Linux client, fully supported. And again, .NET Core clients are available on Windows side as well. And .NET is something that we specialize in. NCache was initially written in .NET, and now it has a .NET Core version as well, fully supported. On the Redis side of things, the .NET Core clients are not 100% supported, right? So there are third-party support for that matter. So primarily, it's for .NET. It would be very intuitive to use a product which fully supports it. It's written in .NET and .NET Core and 100% natively available in that platform. Any questions on the platform and technology side of things? Otherwise, I'll move on and talk about some performance-related differences between these two products.
Actually, I do have a question regarding the NCache accessing as a messaging platform. Is there any limit to the number of clients that can connect to the cache server?
All right, there isn't any limit. It's NCache is very extensible in terms of how many clients you can connect. As a matter of fact, I have opened a sample, publisher and subscriber. So this is a PubSub sample application, and you can use this as a test where you can increase number of publishers, increase number of subscribers, and also you can increase the message load on the communication channel, and you would see how NCache would scale out. And if there is a scenario where your current infrastructure, the number of servers get maxed out because of the messaging load, you need to add more servers. So it can be extended to linear improvements, right? There are some benchmarks which we have conducted. So if I take you to Elastisoft page, I think this would explain it in a better way. If your hardware capacity gets hit, you need to simply add more servers. And if I give you a quick example of our performance numbers and capacity numbers, by adding more and more server nodes, from 1 to 2 servers, you almost double the capacity of how many requests you can handle, and that also applies on the message traffic between your publisher and subscriber. Similarly, from 2 to 3, 3 to 4, 4 to 5, it linearly improves the amount of requests that you can handle out of the communication platform. So there are no limits on how many clients can connect. Unlimited connections are allowed, and similarly unlimited messages are allowed to be transferred between publisher and subscribers. I hope that answers your question. Please let me know if there are more questions. All right, so next segment is around cache performance. Both of these products, NCache and Redis, are pretty fast because that's the main challenge or problem that they're addressing for the end user applications. NCache is based on TCP/IP based communication. Redis is also very fast, but like I mentioned earlier on, their Linux version is what they recommend. Even we get complaints from the customers that they are not comfortable with Redis because they have a Linux deployment in their environment. And their Windows version is again, it is a ported version, so it has some deployment related issues, and it also has performance related issues. On top of it, like I mentioned, these two products compare in terms of performance with one another, but there are some performance features that NCache specializes in. We have a client cache feature which allows you to boost up performance of NCache, and these features are covered in one of our webinars where we actually talk about 6 different features that NCache has to improve your performance in comparison to what you already have without those features. So native default NCache, there are 6 different options that you can plug in, get started with, and then it would further boost up performance for NCache. So client cache is first feature. It's a client-side cache. It's a local cache that you can create on your web or app server, and it gets created automatically. You just configure it from the management tools, and it allows you to actually have a subset of the data closer to your application, right? And as you fetch data from the server cache, this cache is already saving your trips to the backend data source, and it is improving performance in comparison. But client cache is saving trips to the distributed cache cluster and keeping data closer to your application. And this client cache is in sync with the server cache. So NCache is managing the access to the client cache, configurational part. It's a no-code change option, and it's also managing the synchronization overhead between clients and the server cache. And you can also keep it in process to your application. So you would further optimize the serialization and inter-process communication overhead between your application and NCache. So this is expected to improve performance to some dramatic levels. I used this example where we had one of the customers who were completing a workflow within 46 seconds. We turned on client cache and it brought it down to 13 seconds, right? So that was the improvement that we were able to attain. And then after that, we 13 seconds without proc client cache, and then we plugged in proc client cache version of NCache without any code changes. The same task was done within few milliseconds. So it was a couple hundred milliseconds that we were able to achieve the same workflow. So that's the kind of performance improvements that you can expect, and Redis completely lacks this. This feature is not available in Redis. This is something that we specialize in, and it is a no code change option to turn it on. Then comes bulk operations. That's another performance feature. Both products have this. How NCache bulk operations are different. Redis bulk operations are applied on a shard level, right? So it works on one shard only. In comparison, NCache bulks are supported on entire cache cluster. We have dynamic partitioning concept, and if your objects are spanning over multiple partitionings, Redis calls partitions shards. So our partitions allow you to use bulk operations in combination to one another. It's not going to be applied on one partition and you get the result from it. So that's the difference between. So it's more extensible, it's more scalable in comparison. You can have more and more bulk operation load served from NCache in comparison to Redis. Then two other features which Redis completely lacks is the fast complex serialization and compression. We have our binary serialization that you use by default, where you decorate your objects with serialization, serializable, and then NCache has another option where if you don't want to make any code changes, you can use this feature, and then it also improves performance. It's faster and it's more compact. The serialized stream of objects traveling between your application and NCache back and forth is going to be more compact in size. We're not using reflection. We actually generate the serialization and deserialization code, compiled code, and we keep it in memory, and then we utilize that code when you fetch or actually add data to NCache. So it's going to be 10 times faster in comparison to the regular binary serialization. And Redis completely lacks this feature. So that's another performance improvement that you can turn on and would give you a great performance improvement in comparison. And compression is another feature. We use gzip compression on the client end, and we allow you to specify a threshold. Based on your threshold, these features are configurable from our management tools. If you go to the options tab, you simply need to turn on the compression, and you can specify let's say 50 kilobyte of compression overhead threshold, and after that it would automatically apply that to our running cache cluster. And that's another feature, by the way, where you can apply changes to the cache at runtime dynamically, and Redis does not have this. Any questions on the performance and scalability side of things? I've shown you some of the features which are common and how NCache is better, and then there are some features where NCache completely NCache specializes in, and Redis completely lacks those features. All right, assuming there are no questions, so I'm going to move on to high availability and clustering side of things, how these two products compare with one another. This is one of the key factors, and we get a lot of complaints, and this is one of the factors where Redis users having a deployment in the environment actually move to NCache primarily there because it's not truly highly available in true sense. Both of these are cluster products. NCache is 100% peer-to-peer architecture. It's a TCP/IP based cache clustering. We implemented this protocol. Our partitioning is highly dynamic in nature, and our cluster is self-healing in nature. What essentially means by that is that you can add or remove servers on the fly, and you don't have to stop the cache or any of the clients which are connected to it. You can add any new server on the fly. It's seamless to your end user. And similarly, you can remove an existing server on the fly. You don't even have to notify the clients for it. You don't have to have manual intervention. You can just script it, automate it, and have that script run, and you can bring down servers for maintenance at any point in time. It's a 100% dynamic peer-to-peer, 100% peer-to-peer independent cache cluster as far as server nodes are concerned. In comparison, Redis is not highly available in true sense. It's not 100% peer-to-peer architecture. It's a master-slave concept. You cannot add and remove server in terms of shards. You cannot add or remove shards at runtime. Your slave cannot become master on its own. It cannot be promoted as a master on its own. It could be readable. It can be used as a read only, but if it has to promote to a master, it would not do it automatically. Right, so it's not highly available. NCache in comparison, if a server goes down, its backup, its replica automatically gets promoted to active, and your clients automatically start using it. So there is a connection failover support, seamless reconnection failover, And then self-healing mechanism. If there are 3 servers, it would automatically formulate a 2-node healthy cache cluster without you intervening or getting involved in order to achieve that. Then I've shown you dynamic configurations where you can make changes to the cache cluster on the fly. And then you can also make configurational changes on the cluster on the fly. I've given you an example of compression, but there could be more. You can add more server nodes. Let's say you can add another server here as needed. I'll use this as an example. Let me just create a demo cache here, right? Name the cache. So keep everything default. I'll just add 1 server for now. All right, demo cache already exists. So let me just make 1, 2, 3. All right. So I'll add demo 1 and I'll just leave it here. Right, I'll start this cache cluster and show you that I can add another server on the fly, right? And if there are clients which are connected to it, they would automatically start using the newly added server in comparison. So this is something that Redis does not have. Then another important concept, I'll bring back the GUI tool in a bit, is the split brain detection and recovery, which Redis completely lacks. If there are temporary network glitches, right? If a server to server communication gets broken, typically with distributed caching system, you can have a scenario where both side of cluster, both servers formulate their own cache, independent cache, because they lost connectivity for some time. NCache has a built-in feature which detects it so that you can get notified. Either there could be an email alert to it, there are event log entries, and then it also has split brain recovery feature as well. It would automatically detect it, and if you set up the recovery to be automatic, it would go ahead and start and stop nodes so that it joins into a healthy cache cluster. It has an intelligent mechanism which allows you to recover from those scenarios. You don't have to get involved, and that's another feature Redis completely lacks. Imagine if your cluster goes through a split brain and your team members have to get involved in order to fix it. Imagine the time it would take to actually detect it and then make a decision on how we would recover it in Redis. NCache completely automates this for your end users. And then there are some cluster health events that are propagated from server to client, and you can get notified around those as well. So I have 1 server running. I'll add my box as a client. And what I'll do is I'll open statistics window here, and then from my machine, I'll run the PowerShell command. It's called stress. It takes a cache name. I would simulate some load on my cache cluster, right? So at this point, we only have 1 server, right? So it's getting all the requests, and I'll add another server node on the fly. I just need to add this through the GUI tools or through PowerShell commandlets, right? It's added. I'll just start it. And you notice the request per second is about 500 to 600. Once I would add the other server, this request load would be divided between. Now the request load has gone down. I just need to open the statistics again, and you would see that these 2 servers are now participating in order to handle the request load. So request load is divided between the servers automatically, and NCache did it seamless to your end users. Your end user did not encounter any change, any errors in comparison. So this is the beauty of a truly peer-to-peer architectured cache cluster in comparison to a master slave and not highly available cache cluster as Redis is. Next is a concept, I touched this a little bit in the high availability segment, is the dynamic partitioning. Notice that we only had 1 server, and when we added the second server, we had an active and backup formulated automatically. Now server 1's backup is right here, and server 2's backup is right here. So we're currently running a cache cluster with this state right here with active and backups, and these partitioning this partitioning got created automatically, right? So our shards are truly dynamic in nature. Now if I add another server, it would just create a 3-node cache cluster as shown right here. I can add my box here. Let me just add my box, right? So I can add a 3rd server here. I hope I can add that. All right, I think I have a client installation. Let me just add 100. All right, so All right, evaluation is still active, so I can run this. And now it would just create 3 servers in comparison to 2 servers. So this is the partitioning that I have at this point. So if I bring down a server, it would just heal itself to a 2-node cache cluster in comparison to Redis. And Redis does not have this ability. You cannot readjust shards at runtime. If a shard goes down, cluster itself has to be stopped, and that shard has to be promoted at runtime. It's not able to actually promote at runtime. So you have to manually intervene, and because of non-dynamic shards, it is not able to actually promote the slave to a master. And then another concept is that you need replication as a must for high availability. If you don't have replication, you don't have high availability. That's not the case with NCache. That's another important concept. NCache comes with topologies which support replication, and then there are topologies which don't have replication. For example, this partition cache does not have replication. If there are 2 servers, you would have data partition on 2 servers. If one server goes down, cluster remains working with the available surviving partition. It's not going to cause any downtime for your application, and that's not the case with Redis. You need to have replication turned on as a must in order to have high availability. If you don't have replication, you don't have high availability. So coming back to my example of 3 servers, I'm not too sure if I get the statistics of 100, but yeah, there is an error. Right, so we have 3 servers, and if I just stop the node here, currently we're running about 200 requests on each server, total of 600 requests. So if I just stop one server, I can do it on the fly, and this server's backup is going to be made available on the fly at one of these clients, and then cluster would start functioning. It's taking some time to update the GUI view, but as soon as it does it, you would see the surviving nodes automatically taking all the request load from the cache cluster. So let's wait for some time, and we'll get started on this. Right, so it stopped, and you can now see about 300 requests per second on each server. Right, so that's the beauty of a truly peer-to-peer architectured cache cluster, where you can add more servers on the fly, remove servers on the fly, cluster remains up and working, and there are no errors on the client side at all. So that's the difference between NCache and Redis, where you have to get involved manually. A backup cannot be promoted to an active automatically. If a shard goes down, cluster can have issues. It needs to be stopped in order to fully function it, and then the clients are notified at runtime in NCache. It's part of the protocol in Redis. This is something that you have to do manually. You need to notify clients about the updated shard and the updated hash map in comparison. So this is complete in terms of high availability and data reliability. As far as application downtime, please let me know if there are any questions at this point.
I have a couple of questions here. Ron, you had mentioned serializable attribute. What about iSerializable? Does NCache support items inheriting from iSerializable interface?
Well, our compact serialization is our own implemented serialization protocol for that. We're currently not supporting any custom serializer. That is something which is part of the feature set, right? So if somebody who wants to implement their own serialization and plug in with NCache, that's a feature that is going to be made available in next version. So that's in the pipeline for that matter. Currently, it's not available. Please let me know if there are more questions.
Yes, I have one more question, if I can just get to it. If a server goes down, how does the client know about it leaving? Is there some sort of notification mechanism?
Yes, there are notifications. There are clients, first of all, detect a connection broken. A connection is broken. This is built into the protocol, and then server heals itself. Let's take an example of 3 servers. We had 3 servers. If one server goes down, so cluster would start recovery process. It would make the backup activated automatically, seamless to end users, and then it formulates a 2-node healthy cache cluster where active and backups are formulated at runtime automatically, and then clients are notified about the updated view. And this is all done within sub-millisecond delays. You can control it to recover based on retries, and that's a configurable option. So if a server goes down, planned or unplanned outage, within 1 to 2 minutes, that's the maximum time, but you can reduce it to milliseconds. Cluster would heal itself and make itself available, and clients are notified about it. there is a connection failover support which is built into the protocol, and client use this information and fail over the connections automatically. So it's all part of the protocol.
Okay. Great, thank you.
Very good. So next I'll show you the product in action. I've already shown you a few caches. Let me just get rid of this. I think I'll just minimize it. So we have a Linux side of the cache cluster, and then we have Windows cache cluster as well. I've shown you the monitoring details of both ends. Let me just run a stress testing tool application from Linux. Let me see if there you go. So I'm just going to target my demo cache Linux, hit enter, and this is going to simulate some activity for my Linux cache cluster, right? So I've already shown you how to create a cache cluster. On Linux side, there are some commandlets. Let me just, I'll showcase that in a bit. And then you can right click and you can monitor cluster, the Linux cache cluster. There's a monitoring tool which comes installed with it. It gives you all the, statistic related information from the Linux server in the Windows environment. So that's the workaround that we've done. We extended the monitoring support of NCache on Windows to Linux environment as well, because there are no options on Linux side. On the same lines, if you have, let's say, the cache cluster running on Windows using .NET or .NET Core, that's the cache cluster right here. You can again monitor it using the NCache monitoring tool. So it would allow you to monitor everything in this. Sorry, 100 is not connected because I've stopped it. Otherwise, I have a running client which is using this. Let me just run another client instance of it so that we increase the request capacity load. Let's say I run this test stress application which simulates a dummy load. It takes a cache name, and we have demo cache 123 as the cache. So I'll now see an increase in the request capacity. There you go, because I've simulated more load out of the system, and I can run more and more clients, and it would automatically distribute the load on the given service. Report views available. You can create your own dashboards as well. Let's create one, and you can drag and drop counters. You can see all the APIs being executed against this cache using the API logs. And if I stop it, you can see the execution time, client process that originated it, key. So these are all GUI based tools which NCache specializes in, and Redis completely lacks. Primarily this is because Redis is a Linux based solution, whereas NCache is a Linux as well as Windows based solution, and we have Windows support, monitoring support extended for Linux .NET Core servers, NCache .NET Core servers as well. And you can also see client processes. That's another highlight where you can see all the connected client processes. And default dashboard gives you server side statistics of CPU, network graph, cache size, memory graph, and event log entries built into one centralized place. So that's how good it is in terms of monitoring. Please let me know if there are any questions in comparison. Next, I'll talk about some object caching features. From cloud support, this is one important aspect. NCache is fully available in Microsoft Azure on a BYOL model, and then it's also available on as a managed application as well, right? So you can use NCache cache cluster, and we can manage it for you. And same models are available on Redis side as well. It's unmanaged cache. There's a managed cache, and then they'll also have Azure Azure or Amazon hosted cache as well. One difference between NCache and Redis, I would categorize, be it unmanaged or managed. NCache allows you to create a cache cluster within your VNet or virtual private cloud. You don't have to go across the VNet. And based on our experience, we've seen a lot of performance issues in comparison when we run a cache cluster in our own VNet versus it's external to another VNet. And then you can run server-side code in NCache using NCache cloud deployment, which is not possible with Redis because it's a service. If it's a managed cache, you don't have access to the VMs, underlying VMs, and those are Linux VMs, and Redis does not have these features to start off. One of our customers complained about this, that they're moving to cloud, and what about their server-side code? How would this happen? Would this work out? So we gave them various options. That they can use unmanaged approach, they can use managed approach, and still run server-side code because you control it. You implement it, control it if you want to, and we can control it, and we can use your providers to be running on the server side VMs, but we fully manage it, we fully support it on your behalf. Next is object caching support. I'll spend some time around how these products are different. From expirations, we have absolute and sliding expiration. Redis only has absolute expiration. You can set up a timeout on the items, and as soon as that timeout expires, items are going to be removed from the cache. Then there are various ways of keeping cache fresh. If you have data in the database and also in the cache, data exists in two different places, so you need to come up with some kind of invalidation option, so that data changes in the database, you get notified, and also update the data in the cache, so that you don't have stale data in NCache at all. And for reference data, this makes perfect sense, where you use cache and you put all or some of your data in NCache, and then you have some kind of relationship between your objects and the backend data sources. So NCache has SQL dependency in order to handle that. It is based on notifications. As soon as database records change, database would send event notifications, NCache would catch those and invalidate those items, or refresh those items, update those items automatically. And we have a sample application which demonstrates how simple it is to get started. So you can select a product based on a criteria. You construct a SQL dependency object using SQL cache dependency construct, and give the connection string to the data source query to map the records, and then you attach that dependency to the cache item. You created a product in NCache, set up a property, dependency property, and pass it on the SQL dependency, and then call cache.insert. Right, so our dependency would be added, and this is a feature where NCache specializes. Redis does not have this feature. There are some polling-based DP dependencies as well on the same lines. There are CLR store procedures. They allow you to achieve the same task. So in general, NCache allows you to sync your cache with database. As soon as database changes, you can remove the items from the cache or update them automatically. For update, you need to use the server-side code, such as read through and write through, in order to achieve that. Then we have file dependency as well, again on within our samples. If you go to the .NET or .NET Core samples, there is a section of dependency. We have key-based dependency as well. So you can have one-to-one, one-to-many, and many-to-many relationships captured with the help of this feature. Redis does not have this. And then we can have file dependency, custom dependency, and key-based dependency. This is all built into the protocol. On the API side, NCache is a lot more mature on how to invalidate data when it comes to it. Please let me know if there are any questions around this. Another segment, a very important one, is the SQL and LINQ searching. Since you would use NCache, most important use case is to cover relational data source problems, all the bottlenecks of performance and scalability which are associated with relational data sources. So when you plug in NCache or Redis, you might want to get all the data from the data source into the distributed cache. So if that's the use case, we allow you to use SQL searching directly on NCache as well. So let's say if you move all products in NCache, all orders in NCache, all customers in NCache. So in that case, you don't have to go to the data source at all. One reason of going to the data source could be the criteria-based searching that database gives, where you run criteria and bring that data into NCache and use that result set. But if you have all the data in NCache, you can run searches directly on NCache. So we give you SQL and LINQ searches as part of the API. So it's extendable in such a way that you can use an SQL search where you give the product, the object, and you run the criteria directly on those objects. And you get a reader-based interface to iterate through the result set in a lazy loading manner, right? So it fully supports the SQL operations. It provides logical operations. It has a like operator. It provides in. It supports group by, order by, and it also gives aggregate functions as part of this support, where you can run queries directly on the distributed cache and improve performance as a result of this. And it doesn't stop here. The other option of searching could be LINQ, right? Again, Redis does not have SQL search. Redis does not have LINQ provider. NCache natively supports LINQ. It allows you to run LINQ queries, and I'm using a .NET Core sample for it. All you have to do is define your objects that you've cached. You need to arrange your objects in the cache first. You need to add products, you need to add customers, and all of them has to be in the cache so that you don't have to go to the database at all. And then you can run LINQ queries directly on those products. Here's a product example where we've defined NCache query, made it iQueryable with NCache, and then we've run a LINQ query, and we're getting these results served from NCache directly. Redis does not have these features, and this is where it gets very important that you have a criteria-based search directly from the fast source, and specifically where it gives you the same kind of view as you would get from a relational data source. NCache gives you the API support to achieve that. Then we have groups for logical collections, subgroups. You can have hierarchy between, you can have orders grouped with order keyword, and then you can have another subgroup of electronics orders or electronic products for that matter. Then you can associate keywords, tags, and name tags to again identify objects, a collection of objects with a keyword. Again, these features are not available on Redis side. NCache only NCache has these features. Another important segment is the server-side code. We allow you to run server-side code with NCache. Primarily, this is the data access layer providers that you can implement, and then there are more as well. For example, if I go to the cache, here we have the backing source. So you need to stop the cache. Let me show you this as an example. You can enable read-through. This is a provider that you implement and register with NCache, and NCache is going to call this if your items are not in the cache. So if you call cache.get, what if you don't find that item in the cache? You would, within your application, you would pass on control to data access layer and run entity framework core example, or you would just call ADO.NET query and get it from the relational data source. So you can move this logic to NCache, right? So NCache can call this provider by running this data access layer provider on the server side. And write through is opposite of it. Once you update something in the cache, you update the data source in combination to it. Or you can also do this in an asynchronous manner using write behind. So this is something where NCache Redis does not have these features. So you can put your data access layer with NCache. And I have a source code example of it. It's pretty straightforward. All you have to do is implement the interface. This is our read-through interface, right? We have a sample implementation of this as well. So you need to implement the read-through provider, and then you initialize the data source, dispose the connections, and within this you have your own logic to get the data from the backend data source. And you register this with us, and we will call this provider. It's your code that NCache would call at runtime. And write-through is opposite of it. It's write-through provider, again init, dispose, and add to source methods, which allow you to update the cache and database in combination to one another, but NCache calling this on your behalf. Cache loader is another interface where you can pre-populate the cache using a server-side code. And these server-side codes are available on .NET as well as on .NET Core side of things as well. And again, I'll bring back the deployment part. Somebody who is comfortable with .NET, somebody who's a .NET developer, they would like a solution which offers these features natively within .NET or .NET Core. Redis, first of all, does not have these features, and even if it has those features, you would have to go write those features in C++. So I'm not sure if their roadmap covers these features, but NCache right now has all these features available, fully supported, and we have actual production deployments who are using these features for that matter. And then we have some map reduce, entry processor, some compute grid related features where you can register these with NCache, and you can perform calculations on NCache caching platform. It could be calculations on the data which is in the cache, or it could be general calculations that you need as part of NCache. You use NCache infrastructure as a grid, and you get computations processed by using the caching service. Redis does not have this supported in their framework. A few important concepts. NCache has a WAN replication feature. It allows you to replicate data from one data center to another without any code changes. It's part of the same product, where you can have active passive for DR scenario or east to west migration, one-way transfer of data from one data center to the other, or it could be active deployment where both data centers are transferring data to one another. Both sites are active, and you just use the bridge for that matter. Without any code changes, you can set up a bridge, and you can connect two caches in an active passive or active, and it would automatically start consuming data, transferring data from one end to the other. And it's an async replication, so it's not going to impact the performance of the active clients. Again, it's something which NCache specializes. Redis does not have this support. Towards the end, I'll just focus on some of the caching topologies. Local cache is supported on both ends. Client cache is only supported with NCache, in-prog and out-prog. NCache also has mirrored cache, replicated cache, partition, and partition replica cache, whereas Redis only has partitioned cache, where they have shards and not highly available, and then they have shards with replication. Again, if they don't have replication, they don't have high availability. In NCache, if you use partition cache, although you don't have replication, you still have high availability. And then we have data balancing and other features on the clustering end. Cluster connection retries, automatic heartbeat mechanism, client to server keep alive, all the good stuff is covered within these topologies. But just looking at the list of topologies, NCache has a lot more topologies in comparison. For smaller configurations, for medium configurations, and also for enterprise level configurations, it has options for every deployment. I've already given you insight into the GUI tools. We have GUI based tools on Windows for both Linux as well as for Windows environments. We have PowerShell tools on Windows as well as on Linux environment. NCache monitor tool is another aspect. We have log analyzer tool. We have Windows event logs. We have dump and reload data tools. So it's pretty advanced in terms of management and administration capabilities that it presents. On the other hand, Redis comes with command line and admin and monitoring APIs with command line and PowerShell support. So it's not that extended in terms of GUI based monitoring or the kind of tools that they offer in comparison. I can show you a quick list of tools from, if you go to the bin and if you go to the tools, these are all command line tools that NCache also has. And we have PowerShell tools, commandlets that are also available to fully manage everything and fully script it as far as deployment and configurations are concerned. And from ASP.NET standpoint, NCache has ASP.NET Core sessions. Redis also has those. We have regular sessions as well. We have multi-site support for that. Redis lacks that. We have view state for web forms. Redis does not have that. And then we have ASP.NET Singular backplane. Redis also has that. And then we have ASP.NET output caching and response caching. So it's extended in terms of advanced features. It is multi-site, session store provider. Redis is a single site in comparison. And then we have PubSub messaging. Both have PubSub messaging, but NCache specializes by using continuous query. You can use SQL based data sets mapped in NCache because NCache has SQL search. So you can have an SQL based criteria setup and you can get events based on that. Redis does not have this feature. Then we have official support of NHibernate provider for .NET and .NET Core, and then we have Entity Framework Core and Entity Framework older Entity Framework ADO.NET for Entity Framework and Entity Framework Core with some extension methods of EF Core, fully supported by NCache. And Redis does not have this. Redis have an NHibernate not official provider which you can use as integration for it. From security and encryption standpoint, we have authentication and authorization based on LDAP and NCache configurations. They have text-based authentication. We have encryption providers. I'll quickly show you this and conclude it. If I go here to the security tab, we have security that you can set up, and then we have encryption providers. You can choose from regular DES and AES or AES FIPS compliant encryption, and this is a no code change option for NCache. Redis does not have this at all. And on top of it, one of our customers requested TLS, and we used that opportunity and started supporting TLS, transport layer security between client and server. End-to-end, communication is secured between client and server. So that's something that's new, which is available in NCache, and Redis does not have this. So this brings us to end of our presentation. I tried to cover all aspects, all the segments, but please let me know if there are any questions. Otherwise, I'll hand it over to Nick.
Thanks a lot, Ron. This was very helpful. It was a very detailed comparison of NCache and Redis. If there are any questions, kindly guys type them in, and I can ask those right now. Ron, there's a question regarding samples. Do we have .NET Core samples that we ship out with the product?
Yes, we do. As a matter of fact, I was showing all .NET Core samples. So if you go to the samples, there are .NET and .NET Core samples. So all the samples that I was showing were all .NET Core. So these come installed with NCache.
Okay, very good. So without any other questions, I'd like to thank everybody for joining us. We have another session tomorrow as well, so in case you missed something, you can rejoin us tomorrow at 2 p.m. Eastern US time, and we can cover some of the stuff there. If you have any additional questions, you can reach us at support@alachisoft.com, and any sales-related questions, you can always send us an email at sales@alachisoft.com. We can cover some of the leftover questions here that require additional detail. We'll be able to get back to you via email. Thank you very much again, everybody, for joining us. Thanks, Ron, and we'll see you next time. Bye-bye.
Thank you.